We will start by creating one sample table. I will create table tab products with 3 columns. Columns color, size, and quantity. So I will run this statement, and then I will insert 3 rows into this table with this insert into statement. So I will run this, and then we can read from our table to see how it looks like. So this is our sample table. I will now clean my screen. We will now talk about returning clause. When we execute select statement, we will get our result, and that result will be our feedback. But when we execute insert, update, or delete, they will just silently do their job. There will be no feedback. For example, if I update some data, I will update some rows, but I want to know what rows were changed. And for that, I need to run another statement like this select statement, and now I can see what rows were changed after this update. But this means that I have to write 2 statements and that my database must to execute 2 statements. And I want to avoid that. So instead of 2 statements, I will use only 1 statement, but that statement will use returning clause. So here I have such a statement. It will insert some values inside of my sample table. These are the values, and it will return those values that were inserted. And it will return data from color column, size column, and quantity column. So if I run this, I will see all of the rows that were inserted in my table. And we can do the same thing with delete and update statement. So now I will show you an example for delete statement. I will delete some rows from my table, and I will return those rows, but I will only return values for size and quantity columns. So the result will only have 2 columns, and we have deleted only 1 row. We can do the same with update. So I will give you another example. This time we will update some rows, and for those updated rows, we will return new values. So I will run this, and we can see that new value is 40, and that value will be returned instead of our returning clause result. We can also create some expressions inside of our returning clause. For example, we can use aggregate functions. So I will update again our sample table, but I will return a count of star to see how many rows were updated, and I will also see what is the sum of quantity for those rows. So if I run this, I will get a result where we can see that only 1 row was updated, and instead of that row we have a new value 60, so the sum will be 60. We can also create simple expressions with operators like this one here. So I'm deleting value 60 from a sample table, but I will return that value increased by 15. So I will get 75. Now, only simple expressions can be used inside of returning clause. For example, if I try to run a statement like this one that is using group by, something like this will not work. So I'm trying to return color and sum of quantity, but grouped by color, and this will not work, and this is not allowed inside of the returning clause. I will now clean my screen. From recently, it is possible to reference columns by their position, not just by their name. This is possible to be done inside of the order by clause. So I will give you an example. So we can order our table by columns color and size, because those columns are first and second inside of the select clause. So if I run this, this will work. We can do the same with group by clause. So I will group by my color column, but instead of saying group by color, I will just say group by 1. So I will run this, and this is also working. I will now clean my screen. When we are using group by, we can only group by those columns which are not aggregated. If we want to group by all of such columns, then we can use group by all. I will give you this example here. So here I have 2 not aggregated columns. So instead of saying group by color and quantity, I will just say group by all, and this will work correctly. Similar to that, we can use order by all. So we will order our table by all of the columns. So we have columns color, size, and quantity, and we will order by all of those columns in ascending order. So if I run this, Monet will accept this syntax, but we can see that order is not in ascending order, and this is a bug, so this is not working correctly. Instead of using this keyword all, we can use star. So we can say group by star, and we will get the same result. So this will give the same result as previously, and we can use order by star, but just like previously, we will have a bug, so we will not get a correct result. We will again get the wrong result. I will now clean my screen. When we compare something with a null, the result will always be null. For example, is this string equal to this null? Well, we don't know, so the result will be null. And if we compare null and null, so if we say select null is equal to null, we will again get null. We don't know whether they're the same or they are not the same. In order to solve this problem, we will use one other operator, and that operator is distinct from, and there is a version is not distinct from. And this other operator will always return true or false even if one of operands is a null. So now we will see an example for is distinct from operator. So is this null distinct from this other null? Well, it is not, so we will get false. And if this null is not distinct from this other null, well, in that case the result will be true. We can do the same with some string and a null. For example, is this string distinct from a null? Well, it is, so it is true. And is this string not distinct from a null? Then the result will be false. I will now clean my screen. We will now talk about check constraints. Check constraint is a type of rule which specifies a condition, some Boolean expression, that must be met by each row in a database table. And this rule will limit acceptable values for data. I will first show you all of the data that we have inside of our sample table, and then I will give you an example for check constraint. This is one statement that will alter our table. It will add constraint with this name, and that constraint is of check type, and our constraint is that the value in quantity column must be less than 1. But we already have values that are bigger than 1, so this will fail. So if I run this, this will not work. Instead of that, we have to change the value inside of the check constraint. So if we set our constraint that quantity column is less than 100, which is possible because all of these values are less than 100, then this will work. And now we can check our constraint for the new values. I will use insert into statement, and I will try to insert a value 111. And this is bigger than 100, so this should be prohibited, and this will not work. On the other side, if we try to update our table, so if we try to change some value to value that is bigger than 100, this will also fail because this is not allowed. So only if we change some value to the value that is less than 100, then this will work. I will now update my table. I will change this value 30 to 99. 99 will satisfy our condition. Then this will work. And if we now read from our table, we will see that the values that we have in quantity column are all less than 100. I will now clean my screen. We will now talk about different ways how we can create check constraints. We already created constraint on the quantity column. That quantity should be less than 100. I will now add another check constraint on this same column. I will say that quantity should be bigger than 0, and this is allowed. We can have two constraints on the same column. But it is much better to connect two constraints into one constraint, because we don't have to maintain two constraints, we only have one constraint. So we can say that quantity should be bigger than 0 and smaller than 100, and then we can connect those two conditions with AND. So we can create a complex expression, and this is acceptable. Beside this, when we use the same column inside of complex expression, we can use two different columns inside of our expression. So we can say that either color should be equal to red or size should be equal to XL. And we can use these two. Beside this, when we use alter table to create a check constraint, we can create check constraint during the creation of a table. So I will create another table. This table will have two columns, price and quantity, and then we will add constraint with the name valid orders that will check this condition here. So we can create check constraint during the creation of a table. Now, until now, we talk only about constraints at the level of a table, but it is also possible to create a constraint at the level of a column. That constraint will only reference one column. I will give you an example for that. So here we have a new table, and for this new table we have two columns. In this second column, we'll have a constraint that that column should be less than 999. If I run this, this will work. But what is now the name of this constraint? Well, the name will be created automatically by Monet, and it will have this form. So first we will have table name, then underscore, then the name of a column, then underscore, and then the word check. But it is much better to always give a name to constraint. So I will show you this other syntax. This other syntax will also create a check constraint at the level of a column. So we have this column here, but here we also will give a name to our check constraint. So this is much better solution. I will now clean my screen. We will now talk about some limitations of the check constraints. First is that check constraint can only refer to one row. So if we have a statement like this one, where we are using aggregate function inside of the check constraint, this aggregate function will refer to all of the rows, so this will not work and this will fail. This also means that inside of the check constraint we cannot refer to columns that are in some other tables. The other limitation is about performance. We should always avoid complex conditions, especially if they are referring to several columns. We should strive to creating simple check constraints on only one column. I will now clean my screen. We will now talk about the relation between check constraints and nulls. Previously, we have created a table with some check constraints. I will now insert a new row in that table, but I will insert a row with nulls. And because our check constraints are not capable to investigate nulls, then this will work. And we can confirm that if we read from our table, we have a new row in our table. And similar to that, if we have a table, then we can create a check constraint like this one. Here we are comparing column with a null, and this will always be null. So in order for our constraint to work, the result of condition must be false. So this constraint here is useless. And if we now try to insert any row inside of our table, then our constraint defined in this way will not work. So if we try to read from our table, we will see that new row was successfully inserted. I will now clean my screen. We can find a list of all of our check constraints in the view information schema check constraints. So I will run this statement here. I will read from that view. I will search for the table with this name. So if I run this, we will see constraints that are defined on this table. And now we will see how to delete check constraints. First, we can delete them by their name. So I will use alter table, draw constraint, and then I will provide the name of a constraint. And the other way is to delete a table. So I will now delete a table with the name tab1 column named. And then I will in such way delete all of the constraints on this table. So now we can again read from our system view. So we can read from this view. We will search for this table1 column named, and we will search for this constraint ZZ which were deleted previously, and we will see that for them there are no more check constraints. I will now clean my screen. Like is a pattern matching operator, and this operator will help us to find patterns in a text. This operator is based on two wildcard characters. The first one is %, which will replace any set of consecutive characters, and the other one is underscore, which will replace exactly one character. I will now give you some examples. So we have these three examples. First, if we are using a percent sign, it will match any string because any string is actually a set of consecutive characters. If we are using pattern like this one, then this will match to any string that has exactly 3 characters. And here we are using combination of a letter and percent sign, and this will match any string that starts with A and then have some characters after that. We can also take a look at these other examples. So I will give you 3 more examples. Here we are looking for substring inside of this string. Here we are looking for string that has exactly 4 characters. The first one is A and the last one is A, but between them we can have anything. And here we have a pattern that has 3 letters, and then it also has the 4th letter, and because our string has only 3 letters, this will not match. Now, beside like, we also have a version I like. So if we are using a statement like this one, this will return false, because here we have lower letters and here we have upper letters, but we can use I like to change that, because I like is case insensitive, so then we will get true. Beside like and I like, we can use negative version. For example, we can say is M like M, and this will be true, but we can reverse this logic by using select M not like M, so then we will get false. Default escape character is backslash. So if we have a string like this one that has percent sign and then underscore, how we will create a pattern to find these 2 characters? Well, we will use escape sign before percent sign and before underscore here. And if we run this, this will return true because of this. We can also change what sign will be escape sign by using escape clause like this. In this case, sharp is our escape sign, so this will also return true. I will now clear my screen. If we have to work with more complex patterns, then we can use regex replace function. So I will give you an example. This function will accept the original string, then inside of that string it will search for this pattern, and this pattern is defined by using a regular expression, and it will replace that pattern with letter Z. So here we are searching for M followed by any 2 characters, and those will be replaced with Z. So we will get ZAM. This function is by default case sensitive. So if we are mixing smaller letters and upper letters, we will have no replacement because this is case sensitive function, but we can turn on case insensitivity if we add this 4th argument, and for that 4th argument we are using global modifier I. So if we run this, this will return replaced substring. Beside I, we can also use M, S, and X. And it is interesting that we cannot use global modifier G because G is turned on by default. Here we will replace S with P, but it will be replaced on every position, so we will get 3 P's. I will now show you what happens when we use modifier M. In that case, the start of each line will be treated the same as the start of a text. And here we have a line break. That means that here we have 2 lines, so the result will be 2 stars. We can also use S. S means that line break will be treated as any other character, so then this pattern here will match this thing here, and we will replace everything with X. We can also use X as a modifier. In that case, spaces inside of pattern will be ignored, so this will succeed. We can also see that if we have to use backslashes, then we have to escape them with another backslash, so we need to use 2 backslashes. So if I run this, this will be successful. We have replaced this name with this name here, and also we can use numbered capturing groups. So that means that when we look for groups inside of this string, we can use this syntax to replace order of words. So instead of having first name and then the last name, we will reverse that. So we will have first the last name and then the first name. I will now clear my screen. At the end, we will see how truncate can affect serial data type. I will create one table that will have serial data type for its first column, and then I will insert some data into this table. We will only insert data into second column because in the first column we have serial data type, so these numbers 1 and 2 will be automatically created. I will now truncate this table, but I will use subclause continue identity. Continue identity means that Monet will remember the last serial number that we have used. So if I run this, we now have no more data in our table, but if we now insert a new values, we will not get values 1 and 2, but now we will get values 3 and 4, because we are continuing identity. And this is not default behavior. Default behavior is restart identity. So I will again truncate this table. I will again insert some values inside of the table. And if I now read from this table, we will see default behavior. And default behavior is that we will have numbers 1 and 2.